Network analysis and two-port networks. We have a common question asking what is the condition for a two-port network to be symmetric, and that procedure is like we have to evaluate the impedance at this point, and also we have to evaluate the impedance at this point. When these two impedances are equal, we can say that the two-port network is symmetry, and during that equating that procedure itself, we can evaluate the condition for the two-port network to be symmetrical in terms of Z, Y, H and ABCD parameters. Alright, so what is that procedure is like, remember always for the same procedure for all the four two-port networks. Like what we have to do is V1 is plugged in with Vs and impedances. It's all about calculating the impedance at this point and impedance at this point. Remember, while calculating the impedance at this point, we'll make I2 equal to 0, and while calculating the impedance at this point, we'll make I1 equal to this 0. That's the procedure. Alright, the condition is when we go for this one, I'm making I2 equal to 0, we'll have to evaluate Vs upon I1, and while calculating the impedance at output port V2, now V2 is plugged in with Vs, making I1 equal to 0, and we go in search of the ratio V2, so Vs upon I2. So for the two-port network to be symmetric, these two should be equal. And while equating these two equations, we'll get that condition, and then we say that yeah, this is the condition for the two-port network in terms of Z parameters and Y parameter, H parameters, like that. Alright, so making use of those conditions, and to that standard equations representing the Z parameters, we have V1 equals Z11 I1 plus Z12 I2, isn't it? And the second equation, guys, actually we don't need to go for the second equation while calculating the impedance. Making use of this one and this one, what do we have is V1 is plugged in with Vs. Alright, and Z11 is I1 plus Z12 I2 is 0, so this is what we have, right? And we have that equation like that ratio Vs upon I1 equals Z11. This is the one. Input impedance is this one, and on the other hand we'll have to go for this one, which ratio Vs upon I2. Considering the second equation, what do we have for that Z parameters? We have V2 equals Z21 I1 plus Z22 I2, isn't it? And once again making use of this condition, V2 is plugged in with Vs, V2 is plugged in with Vs here, and with this one I2 making 0, we have this one which equals Z22 I2, and we have to go in search of this ratio Vs upon I2. So Vs upon I2, Vs upon I2 equals Z22. For the two-port network to be symmetrical, this and this should be equal in the sense Z11 should be equal to Z22 for a two-port network. I mean, this is the condition in terms of Z parameters for a two-port network to be symmetrical. What is that? Here we have, in terms of Z parameters, we have Z11 should be equal to Z22. This is one. Alright, and when it comes to that of Y parameters, those two standard expressions, only during that evaluation for Y parameters it takes a long process. Alright, what do we have? I1 in terms of Y parameters, Y11 V1 plus Y12 V2. Alright, and on the other half, second equation is I2 equals Y21 V1 plus Y22 V2. What is that condition again? Here the same condition to be plugging over here. What it is the first one, V1 should be equal to Vs, alright, and I2 should be equal to 0 for the first one, for the input impedance to be calculated. In that way we have I1 will be equal to Y11 Vs plus Y12 V2. Now I2 is made 0. We don't go for any other changes over here. Coming back to the second equation here, calculating the input impedance, I2 equal to 0. So we have a 0 which equals Y21 V1 to be plugged in with Vs. So we have Vs plus y22 v2. y2 as it is. Guys, from this expression, calculating the input impedance over this side, so what ratio do we need? Vs upon I1. This has to be eliminated, so we'll have to find out that V2 from here. So from this expression, what do we have? It's positive. This time it's dragging it to this side, it will be negative y21 into Vs upon y22, which equals V2 from this one. Now this V2 is plugged in over here, which gives us I1, that will be equal to y11 Vs as it is, plus y12 from here, and V2 plugging in this one, this will be no more positive, this negative appears over here, y21 into Vs upon y22. Alright, so Vs can be taken out as common from this one and that one, so braces comes over here. Alright, and simplifying this one, what do we have? Guys, simplifying this one, what do we have? It's a, what did we have? y22, isn't it? So y22 in the denominator, and this gets multiplied, isn't it? Upon 1 y22 y11 minus y12 y21 into Vs, which is equal to I1. Alright, so that is for, and from this expression, Vs upon, we will be searching in this one, Vs upon I1. So Vs upon I1, this flips up, so what do we have? y22 upon y22 y11 minus y21 y12, this is for Vs1. In the same way, we will have to find out for Vs upon I2, and equating that to will give us the condition for the two-port network being symmetrical in terms of y parameters. All right, once again getting back to that two standard equations for y parameters. What do we have? I1 equals y11 v1 plus y12 v2, and on the second equation will be I2 will be equal to y21, and this condition, now V2 will be equal to Vs and making I1 equal to 0. Alright, so the second equation is I2 equal to y21 V1 plus y22 V2, and here for this condition, to evaluate this one, we will have to go for this condition, I1 equal to 0, this is 0, and V2 equal to Vs, in the sense this is no more V2, it will be Vs. Also over here it will be Vs. This, whatever we have done for this, we'll have to do for this one. All right, so here we have that Vs over here, I2 is over here, this is like no way connection for this ratio, so this has to be eliminated. So from getting back to this one, what do we have? y11 v1 will be equal to negative times y12 vs, isn't it? And from this one very expression, we have v1 will be equal to by y11. Now plugging in this condition over here, what do we have? I2 will be equal to y21, and in place of v1 we'll have to plug in this one, so negative appears, this appears over here, y12 vs upon y11 plus y22 into Vs. Guys, previously as we did, common from this one and this one, so braces comes over here, and simplifying this one, what do we have? y11 and this one, cross multiplying, we have y11 y22 minus y21 y12, which is equal to I2 and Vs. Alright, so what are we in search of? Vs upon I2. So Vs upon I2, this flips up, so what do we have? y11 and y11 y22 minus y21 y12. So these two equations should be compared, and here itself we can say that when this is equal to this, the denominators gets cancelled. Alright, when this equal to this, the denominators gets cancelled, and that condition for symmetry in terms of y parameters, once again similar to that one. These two are equal, Vs upon I1, Vs upon I2 equal, and we have that condition y11 equal to y22. Guys, this is in terms of y parameters. On the other hand, the same procedure for condition for symmetry in terms of h parameters. What do we have is, we'll have to recall that two expressions for h parameters. What is that? We have v1 equals h11 I1 plus h12 v2, and the second equation being I2 equals h21 I1 plus h22 v2. And once again the same procedure, we'll have to make use of this condition and we'll have to find out this ratio. Making use of this condition, we'll have to find out this ratio, and equating that will give us the relationship very much similar to this one. Alright, so the first one, v1 will be Vs, v1 will be plugged in with Vs, which equals h11 I1 plus h12 v2. Alright, so we'll have this one, and here we have 0, which equals h21 I1 plus h22 v2. Which one to be made 0? I2 to be made 0, it's a 0. And what are we in search of? Vs upon I1. So we'll have to somehow eliminate v2. Eliminate in the sense, we'll have to substitute this v2 whatever we obtain from over here. Alright, so with this one, which equals h22 v2 will be negative h21 I1, and also v2 will be equal to, we don't have this anymore, so this appearing over here, it's a h22. This condition over here, plugging over here, what do we have? Vs, which is equal to h11 I1 plus h12 as it is from here, but v2 to be plugged in with this one, so that negative appears over here. We also have h21 I1 upon h22, and it's I1, I'm sorry, and also I1 can be taken as common from both the terms, so a braces appears over here. And simplifying this one, simplifying here itself, what do we have is, hey guys, so Vs upon I1, what do we have? h22, and this will be h11 h22 minus h12 h21, that ratio Vs upon I1 which we are searching for. And for this one, considering what, again getting back to this expression, what is the condition for the second impedance to be calculated? V2 equal to Vs, guys. Here in this very expression, taking the second one, what do we have? V2 is Vs and I1 equal to 0. This becomes 0, and we are in search of Vs upon I2. So this equation itself gives that. We don't need to do this much of practice. All right. So I2 will be as it is. I1 is 0, so this will be 0 according to the condition, and h22 will be as it is, and V2 will be Vs. And what are we in search of? Vs upon I2, which is equal to 1 upon h22. For the two-port network to be symmetric, this one Vs upon I1 and Vs upon I2 should be equal. In the sense, this will be equal to 1 upon h22, and this gets cancelled, this one. That condition in terms of h parameters, it's h11 h22 minus h12 h21 should be equal to 1. That condition for symmetry in terms of h parameters, this is the one. All right. On the other hand, ABCD parameters, be careful over here. We don't remember one equation regarding the negative appears in the ABCD parameters. All right, it's like what is that equations? V1 will be equal to AB, isn't it? We have V2 minus I1, the first equation, sorry, I2. And the second equation, we have I1 equals C D with a V2 minus I2 over here. These are the two equations representing ABCD parameters. Alright, so once again the same condition, these conditions plugging over here and evaluating for Vs upon I1. Alright, so V1 is Vs, which equals AV2 as it is, and I2 is 0, isn't it? So we'll have only this one. Alright, we'll have only this one. And in that case, getting back to the second one, we have I1, no, that is not reduced. We'll have C times V2, I2 is 0, so we don't have that one. Alright, so from this very expression we can have V2 equals I1 upon C. So this V2 expression as it is plugging over here, what do we have? V of S will be equal to A as it is from the previous expression. V2 is plugged in with I1 upon C, and we are in search of Vs upon I1, that is A upon C. Alright, this is equation, one of the equation to be compared with. On the other hand, the second condition, what we have is now V2 will be Vs and I1 0, V2 will be Vs, I1 will be 0, only that changes. Alright, so we have V1, no, it's not redundant, and A times Vs, we have that I2 also, B times I2 from the second expression. Alright, V2 is made Vs and I1 is 0. So here on the other hand we have I1 is 0 over here, which equals C times V2 minus D times I2. We don't need to do much exercise. Why? Because here itself we get that ratio Vs upon I2 here. From this very expression, what we have is C V2 will be equal to D I2. We are in search of that, guys. I'm sorry. V2 here should be Vs. Alright, so it's not V2, Vs. So Vs upon I2, that will be equal to D upon C from rearranging this one. So these two, Vs upon I1 and Vs upon I2, should be equal in the sense A upon C will be equal to D upon C, and that condition A equal to D. This one, A equal to D. For the two-port network to be symmetric in terms of Z parameters, in terms of Y parameters, in terms of H parameters, and in terms of ABCD parameters.